This is part C on quadratics, taken from the third section in Unit 9. We're going to look at number 2. A rectangular pen is made with 50 meters of fencing on 3 sides. The fourth side is a stone wall. Find the greatest possible area of such an enclosure. So here's our stone wall. Here's our fence. Rectangular, and it's got some length, capital L for length, and some width, W. Find the greatest possible area. So in the perimeter of this fence, we know that W plus W plus L is got to be our 50 meters of fencing, or 2W plus L is 50. We want the greatest possible area. We know the area of a rectangle is length times width. So in our 2W plus L equals 50, we could solve for L and get L as 50 minus 2W. So the next step is to substitute that 50 minus 2W in for L. So we know the area is length times width. Instead of writing the length times width, we're going to substitute in the 50 minus 2 times W here. And now we can distribute the W here to 50 and negative 2W. And we get the area is equal to 50W minus 2W squared. I'm going to rewrite it as the area is negative 2W squared plus 50W. To give you a visual here, so this is the width that we use in the area. We get this upside down parabola. That's our equation, A equals negative 2W squared plus 50W, where the vertex is at the maximum here. So if we can find the vertex of this, then we can solve. So we want to put this in vertex form. I'm going to factor out the negative 2, and I'm left with W squared minus 25W so then we want to complete the square here. We take half of the negative 25 and square it. So we're going to get 25 times 25, which is 625, over 2 times 2, which is 4. This really has a value of negative 2 times this value. So negative 2 times 625 over 4 is going to be negative 625 over 2. So that's what I'm going to add. 625 over 2, and then we can factor this, and we get the area is equal to negative 2 W minus 25 over 2 squared plus 625 over 2. So our vertex is 25 over 2 comma 625 over 2. The first number stands for our width, the second number stands for our maximum area given that width. So it said find the greatest area, 625 over 2. which we can write as a decimal, 312.5 square meters. Number 8, an arrow is shot vertically upward with an initial speed of 64 feet per second. Its height after t seconds is given by h equals 64t minus 16t squared. How high does the ball go? I'm going to rewrite that equation as h is equal to negative 16t squared plus 64t. I'm going to put this in vertex form. This is a quadratic. Again, we get that picture. I'll draw it down here. We have the height of that ball over time, and so that ball creates this parabola. And the vertex is where we have our highest point. So I'm going to focus on getting it in vertex form. Factor out the negative 16. You get t squared minus 4t. Leave a little room to complete the square. We cut 4 in half and square it. We end up getting 4, so I'm going to add 4 here, which really has a value of negative 64. So I add 64. And now factor, so the height is negative 16 times t minus 2 squared plus 64. Our vertex is going to be 264, where 2 is the time in seconds, and 64 is our maximum height. So now if we look at part A, it says how high does the ball go? It goes 64 feet. How many seconds does it take to reach the maximum height? 2 seconds. Both of those came from our vertex. When does the ball hit the ground? Now, vertex form doesn't help us when the ball hits the ground. When the ball hits the ground in our picture, that is at an x-intercept. And so we're going to go back to our original equation. H equals 64t minus 16t squared, and plug in 0 for the height, because that's when it's hitting the ground. I'm going to try to solve this by factoring. I'm going to factor out it's enough to just factor out a t. We could have factored out 16 or negative 16 as well, but this will work. And so we end up with either time is 0 or 64 minus 16t is going to equal 0. Solve the second one. We get negative 16t is negative 64. Divide by negative 16 and you get t is 4 seconds. So when does the ball hit the ground? Either at 0 seconds or 4 seconds. 0 seconds is when the ball is hit, and 4 seconds is when it lands. And there's a little issue here, which starts by talking about an arrow shot vertically upward, and then now it's talking about a ball. It should say arrow. And so our answer is 4 seconds. Number 12, the equation for height, h, of an arrow is h equals negative 3/4 t squared plus 6t plus 6, where t represents time in seconds since shooting the arrow. Find the time needed for the arrow to reach its maximum point. So we're talking about a vertex when you hear maximum. And then how high will it go? Again, that's talking about the vertex. So if we find the vertex, we answer both these questions. So h is equal to negative 3/4 t squared plus 6t plus 6. I'm going to get rid of the fraction first by multiplying everything by 4. I get 4 times h is equal to negative 3t squared plus 24t plus 24. And then I'm going to factor out the negative 3 from the first two terms and get 4h is negative 3 times t squared minus 8t. Leave a little room to complete the square, keep the positive 24 at the end. Complete the square, we take the negative 8, cut it in half, and square it. Get 16, which really has a value of negative 3 times 16, which is 48, negative 48. So we're going to add 48 at the end here. So now 4 times h is negative 3. Factor this to t minus 4 squared plus add 24 and 48 together to get 72. And then the last thing to do is to solve for h. So we're going to divide by 4. You divide these three pieces by 4. And you get the height is negative 3/4 t minus 4 squared plus 4 goes into 72 18 times. So our vertex is 418, where 4 is our time and 18 is our height. So find the time needed for the arrow to reach its maximum point. It took 4 seconds. How high will it go? 18. And our units here, it doesn't specify, so I'll say 18 units. I guess, yeah, it does say seconds for time, so I'll use seconds. So we'll stop there.